let him take it away.
All right. We got sound? All right, cool. All right, so I've already said it a number of times, but again, I'm Adam. I'm tech artist here at Bully. Today I just kind of wanted to talk to you guys a little bit about render textures. They are Unity Pro only. But nonetheless, I just think that they are so incredibly cool and handy for so many things. I just thought it'd be a great topic to kind of cover today. So to start off with, I'm just going to start with some really basic kind of an introduction to what a render texture is and how to kind of set them up, what they do. I'm not sure how familiar everybody is with them, so we'll just start right from the very beginning. So you can see here in my project, I got a couple different topics I want to cover. I'll try to keep them kind of short. I might tend to ramble a little bit on some of the more techie stuff, but I'll try to keep it a little bit quick. And if anybody has questions as I'm going along, just feel free to, raise your hand, whatever. I'll definitely take questions as we go. So to start off with, render texture is very simply just a texture that's a little bit fancier in my opinion. You can write to it on the fly, dynamically change whatever's going on in the scene. So if we create a new one, it's very simple. You can name it whatever we want. New render texture. There we go. And basically you're ready to roll. A lot of these, let's see, here we go. To use it most simply, there's a slot right here on any camera that you have in your scene, which is basically where you'd slap in your render texture. And anything that camera views will then be written to that texture map. So to give you an example, let me just go ahead and play this scene really quick, and you can see what's happening here. Give it a second, I apologize, my laptop's kind of old. Alright, so here we've got what looks like, a character standing in front of the camera. In reality, this is just a plane with a render texture being displayed on it. So if we were to move this plane, it kind of looks like the character's moving, something like that. If we move the character, you'll see that it clips off the edges. So it's just a texture on this plane right now. So here we go in the actual scene view. You can see just this plane object. You can see his idle animation. They run pretty smooth. They're pretty fast. They're not super great for performance if you have a lot of them in your scene. You have to be very careful how many of them you use and how optimally you reuse them and destroy them on the fly. They can definitely eat up memory really fast if you have a lot of large ones sitting in there. So yeah, that's pretty much a quick introduction to how a render texture works. Again, there's our camera. You see as we adjust it, everything's updating on the fly. You can change or animate any of these different aspects of it, rotation, whatever. Whatever it sees, you will see it on your texture map. So that's the easiest way probably to work with them in the editor. The other way that you can work with render textures is through scripts. And here at Bully we usually like to use, well actually solely like to use C#. So all the code today will be in C#. It's not too difficult to convert a lot of this over to JavaScript, but just for the sake of ease, I've got everything in C# right now. So this is my basic code class, just to kind of show some examples of how you may want to create a render texture on the fly using nothing but a script. So here in my start method, you can see we've got a couple calls here, new render textures. It takes a couple different parameters. There's actually 3 different ways that you can do it. You can just pass it a width and a height and sort of a depth buffer, which as you can see here, I made a little comment. This is something I always forget too, but it's 0, 16, 24 standard depth buffer kind of sizes. Yes. Yeah, I should have asked. let's see. There we go. Is that a little bit easier to see? A little more. Can I keep going?
There we go.
There we go. We good?
Good.
Is it big enough?
Good. Yeah.
I can try it one more time. There we go. Now we got to scroll. All right.
Double tap the tab, that way it goes full screen.
Say what?
Double tap the tab.
Oh yeah, good call. There we go. Let me make that a little bit bigger too. How's that? There we go. Oh, we can see it. All right, cool. Yeah, so once you have this render texture, you can do the same thing as you would do in the inspector with it. You can pass it to a camera, set the target texture. You can also do some other trickery with it. There's some built-in methods, or I should say pre-existing methods of the mono behavior, which are on pre-call, on pre-render, and on post-render. And these are all methods that will automatically fire on any camera object. So they're really handy to use anytime that you want to do, you know, some process on a render texture or a visual effect or anything along those lines. You can catch it before it's ever started to even call objects in the scene, which is, you know, a great time to adjust like your field of view, things like that. On pre-render, which is, you know, maybe you want to do some color changes or who knows what, but it's before the actual frame renders. And then of course on post-render is a great time to basically grab a new render texture or anything along those lines because you have a fully rendered frame at that point. Now this one is actually kind of a special method on render image. It's used quite frequently in doing post-process effects, camera effects, things like that. And this actually happens after all three of these have already run. So you end up with this source render texture and a destination render texture. Now, the source render texture is exactly what the camera has seen up to that point, basically, in your camera view, in the scene, whatever. The destination render texture is what's actually going to get displayed to the screen. So you can do a lot of trickery, you know, within this method here of grabbing the source render texture, do whatever you'd like to do to it, and then pass it along and have, you know, cool effects happening on the screen. So I'm not going to get into post-process effects or things like that today. That's like a whole nother talk, in my opinion. But just so you know, it's there, and it's really fun to play with. So if I were to run this right now, I will show you really quick. Oh. Sorry, if I get my windows back. There we go. And I love Unity's UI. It just decides to flip out randomly for no apparent reason. All right, so if I turn this on, here we go. Start this up. And let me just pause it for a second. Basically, those methods will just keep looping every time a frame runs. So you can see I'm already up to 156, and I had it running for like a split second. But you can see the order they ran in: pre-call, pre-render, post-render, render image. The calls that we made to create a new render texture. This is actually a really handy trick I like to do a lot of times, is just give myself a public or a private variable excuse me, in the script that I'm running. It just makes it really easy to preview whatever your render texture is. You can just double click on it. You can see, you know, it's blank right now. We don't have it assigned any kind of camera view, but definitely an easy way to see what it is that your camera is actually looking at. I've also got, let's see here. Well, we've got the source is missing, but we've got a destination render texture here, which is from that onRenderImage method. And you can see this is actually what our camera is seeing currently. So those are some basics of render textures. Really easy if you don't want to mess with them from the script side of things. You can definitely get things done within just the editor itself using the inspector. If you want to do something a little more complex, you can definitely go through script, create them on the fly, destroy them on the fly. You have a lot more control over memory management and things like that along those lines. So that's a basic introduction to it. Any questions before I move on further? I'll start getting into some more fun stuff. Yes?
Can you talk about like how you use it, why to use it? Like,
absolutely. That's exactly where I'm going to step into next. Basically just a few use case examples. There's tons of different things that you can do with render textures. It's really just, I guess it's just up to your imagination. You know, it's whatever you would normally do with a texture, but you can create them dynamically from any number of elements that your camera sees on the scene. So lots of dynamic effects and things of that sort. So, all right, any more questions? Cool.
Yeah.
Sure.
Render image, I hadn't seen that before, and so it's my first time seeing that function. The source and destination that come into that, are those, I'm assuming it's one in the back buffer, or is it just create render targets that you frame?
No, it is basically just the buffer that's coming in, and you'll see it actually in the.
There's always a destination, or is it just right up to this? I think that I just was trying to figure out
There's always a destination as well. Both of those will be populated, I should say. The tricky part about render textures, though, especially if you're doing something like on render image, those values that are coming in, you can only be guaranteed that there's data there during that exact frame, because exactly for that reason, it's coming through on a temporary buffer. A lot of times those things are getting cleared out. It could be full of just who knows what kind of data. You can get all kinds of crazy effects and stuff in there. There's a couple other, yeah, we've had some interesting experiences with that. Oh, and actually another neat thing before I move on. Let me turn this script off. There we go. Get this thing updating again. So the other thing that matters is these clear flags on your camera. You know, of course, skybox. If you got the skybox thing set, you'll see that in the background. Solid color, this is a good example right now. You can just shift that around. You can see it, you know, updating as we go. This one, if I had this thing set up right now with, and actually I'll show you an example of this later on, with depth only, you can actually get, ooh, it's doing something really, yeah, it's not clearing right now. That's usually don't clear, and then it'll go all kinds of crazy. Maybe it's just because I switched it on the fly while it's running. But basically, don't clear, that'll, you know, let it just overwrite. You can do some really cool effects. We've done some projects in the past with drawing and painting, things like that, where it's basically just a camera with a little game object. You shift it around and, you know, it'll just constantly write down to the texture. So kind of cool for doing stuff like that. The depth only is actually kind of cool though. You can get a transparent mask of basically whatever you see on the screen. So actually, let me make that a little bit more clear. Any game objects that are in the scene, geometry, things like that, they will have basically some sort of an alpha value assigned to them. A lot of times it's not always 100% white. Kind of depends on the shaders that you're using, things like that. But basically, wherever there are no objects in your scene will just be transparent. So it's kind of cool for getting some masking effects, things along those lines. But I'll give you an example of that a little bit later on as well. So, moving right along, one way that you can make use of a render texture is to make a mini-map. There are plenty of ways to do mini-maps. You know, you could pre-bake out the imagery. You could do a lot of different ways of doing it. Using a render texture, really quick and easy. If you make updates to the level, you don't have to worry about re-rendering anything out. You have full control over, you know, how basically everything looks. You could do a post-process effect even on that. Various other aspects of it that you have a lot of control on. So if we were just to run this, and this is not super exciting, I apologize, kind of run to the wire, and you'll see that I have this amazing walk cycle where basically he'll float. Pay no mind to that. Pay only, you know, look at only the render texture for the moment. So we see that he's displayed on here as a green dot currently. We got some little enemy dudes. They got some red dots happening. But this setup is nothing more than you know, the basic sort of thing that I showed you guys previously. We've got a let's see, there we go. We've got a camera sitting in the scene. Let me bring this up, and let's sort this real quick so you guys can see it. There we go. So again, we got a little plane with just a camera viewing it, and it has a render texture applied to it. Now, that render texture is coming from, let's see, I actually got him following the character right now. There we go. So we've got this mini-map camera, bring this back up, and it's basically just an orthographic camera in the scene placed directly above our character. Again, usually you want to use an orthographic camera. You can use perspective, however you'd like to do it. But what I really like with orthographic cameras is you can do some nice little like zoom effects if you wanted to, just by changing the orthographic size. So you can have that nice effect of, if you want to have a world map or whatever, something along those lines. Really quick and easy to toss that in there. So I'll leave it at that. Was it set to 3? I don't even remember. We'll leave it at 3. And let's see here. Oh, and last but not least, so another thing about using render textures is you do have increases, like it's an increase in the number of draw calls in your scene because you got another camera rendering out whatever is there. One way to get around that, especially for something like a mini map where you may have tons of characters running, you don't want it, eating up tons of memory, lagging it out. What I've done for this is basically just have a little sprite on each one of the characters. Super fancy little green dot. And I just make use of layers a lot to kind of sort what I want cameras to view. So here, for instance, the mini-map, I've got it set so that we can see everything except for things that are on the player layer. Which I've placed all the enemies and the player. I could have made an enemy layer, but for the sake of speed, they are all on the player layer. So essentially what will happen is this mini-map camera now will only see, the map. It's not going to see any of the actual animated objects. You're only seeing the little sprites, which will always be updated with the character's position, things like that, because they're parented to those objects. And you basically end up with a very simple kind of mini-map that you can scale, move around, do whatever you want with, and you've just got it sitting right there as a render texture. That is one example of what you could do with it. So, let's see. I don't think I need to cover anything else in here. I don't even think I have any do I have scripts? Oh, just my movement script. So that's completely set up in the inspector. There's not even any kind of scripting involved in that. Really quick and easy to do. So, move on to the next one. We've got some dynamic shadows, which actually makes use of the depth setting on the camera. They're kind of cool. But before I do, any questions on minimap type stuff? Pretty straightforward. Cool. Oh, yes.
In that instance, are you literally rendering as twice then?
Yes. Yeah.
It's not like pre-caching. It looks like.
Nope, that is completely rendered on the fly. Another thing that may be useful in this case would be even like an LOD of your level. I mean, the image that you're getting out of it is going to be so small on the screen if it's just a UI element. That's another thing to consider is what's your actual render texture size and how much fidelity are you actually getting out of, say whatever it is that you're rendering, the level in this case. So you could probably drop the resolution of a lot of those geometry models down pretty low. And then even though there are extra draw calls, it's not going to be that much more processor intensive.
Is there a way to
But yeah.
not draw on a specific frame? Like if you wanted it to draw every other frame, you just like disable the camera, or is there any way to
You could- You could definitely do that. You can have it so that basically you could disable the camera every other frame, like you're saying. That would probably be the quickest way to do it. I mean, you could unassign, reassign the render texture, but basically just kind of toggling that camera on and off. That would probably be the easiest. Might look a little bit strange, but it might not be that noticeable. I've never actually tried it before, but that's a good idea.
We had a game with 4 views and we did like just completely serious and I think you're really fast and the camera was out.
Oh, okay. Cool. Keep that one in mind. All right. Any other questions? All right. Moving right along. So, shadows are actually another cool thing that you can do with this. And actually, while putting this presentation together, I came across already a really cool setup. I think it's on the Unity wiki or something like that. Somebody built a really nice like dynamic shadow setup using render textures that actually uses projectors. This one is just a single plane. It'd be good for, you know, more of like a flat level kind of map, something like that, but it gets the point across. But the one that's actually, and it's free, you can just download it, set it up. It's actually a really nice system where you can have these dynamic shadows being cast across multiple objects. You can have it up on, you know, if your character's standing next to a wall and your light source is coming from behind or something, you got a nice shadow going on the ground and up to the wall, everything like that. And you don't have the extra overhead of having shadows cast by all your lights. So this guy here, I do have a light in the scene just because otherwise it's kind of dark. If we turn the light off though, you can see there's just this one. We'll turn it off, and you still see the shadow down here. I apologize if this is kind of small in here. You know what? I need to scoot this over a little bit more if I can. Never mind. Okay, that's as big as it gets. But yeah, let me go ahead and run this real quick. There we go. So we just got this guy twirling around. You can see the shadow updating. It's all good to go. And this is pretty much just a, again, just a plane in the scene with a render texture on it. Now, the difference with this is there's a camera that I've kind of matched to the light angle currently. Just an orthographic camera, and it's capturing the character actually with a black background. I thought I was using depth in this one, apparently not. But I did have to actually make a special shader for this to get it to work properly. One of the things that's kind of interesting is when you're using depth on a camera, is that the alpha that gets written in is almost like a z-depth value of your objects in the scene. So when we look at it, you can actually see almost like a grayscale of things that are kind of closer to you. And I'm not sure if that's really what it is, but it's always what it's looked like to me, and I'm not quite sure where that data is coming from. So the shader that I actually made for this basically just clamps those values, saying, you know, if anything over the you know, value of 0, basically, just clamping it to white. So this character is actually coming out white when the shader processes it.
So,
Yes.
I have a question. You're using this for shadows. Is there any reason using this for shadows? Is there a performance gain to it? Or is it just an example of depth buffer?
There is a performance gain because you're not relying on your lights. You're not relying on the engine to cast these shadows. It's essentially just taking an image of your character, rendering out. You know, you can even take the render texture that's here, and you could drop its size down. You know, we have full control over that to save on even more memory. So this is really great for, say, like mobile applications and things like that, where, you know, having any kind of dynamic shadows, dynamic lights, things like that, it's not really an option. I mean, I guess on the newer devices, you could probably get away with it sometimes, but really to get some nice, smooth performance, you want to keep that to a minimum. And things like this can definitely save on it. So if you have something like, you know, your hero character, or you've got all the lighting baked into your scene, you just need a couple things moving around, this is a pretty good solution, in my opinion, to, you know, overcome that performance loss of having actual dynamic shadows in your scene. There we go. Let's see if I can open up this shader. I'll just crank it up on the fly. But yeah, so we have, you know, some control over the actual opacity of it, things along those lines. You can make a much fancier shader where you could have a nice fall off kind of ramp. You could get soft shadows, things like that. This is literally just basically a clamp shader. So anywhere that your character is, it turns it white. Anywhere that it's not, it just turns it black. So there's no nice soft edges, anything along those lines. But still, like I said, you could do much nicer shader and have that happen. You can also get away with some of these anti-aliasing settings as well, which sometimes will give you better results. You can see sometimes it makes it a little bit smoother around the edges. I'm not really seeing that much difference, honestly. But it kind of depends on the resolution and the combination of all these things. So, yeah, again, using the same exact setup. There's no extra scripts in this one either. Completely set up in the inspector, but a great use for render textures to save on some memory, save on some performance, and pretty quick and easy to set up and get running on pretty much any scene. So I would definitely consider some kind of a implementation of this for mobile platforms, without a doubt. We've used it in a number of projects actually, so it's tried and true. Any questions on this one? Keep moving along. Anything shadow related? Oh, you know, I didn't actually move the, should probably move the camera around so you guys can see it. What I wanted to do initially was actually get this thing lining up to the light as I moved it around, and again, running out of time, but that's another thing that you could do. You know, if you have your light sort of changing direction, or as your character's running along, anything like that, you know, you can have that sort of rotation update as well, so it looks like it's really casting a shadow in real time. So, kind of cool. All right. No questions? We're good?
Does the bigger point on the camera point to his feet? Is that how you get the? I mean, what stops the shadow from like not being centered on his feet?
Oh. Yeah, actually, basically the camera's just hanging out above him. But I've set this object to be exactly there on the ground plane. So anytime you get that rotation, it is exactly like, you know, his feet are. There's a little bit of play in there, which could probably be, you know, finessed. But for the most part, that keeps it clamped right there to his feet. And unless he does something really, you know, some really out of the box kind of animation, it's probably going to stay pretty close to where he is. Again, considering the performance gain you can get on implementing something like this, I think it's a small price to pay to have to finagle a little bit of a texture around. Cool. All right. So, another thing that you can use render textures for is scene transitions. So let's say you got a game that's kind of like, did you guys ever play like Final Fantasy VII, anything like that? Any of the Final Fantasies, really. And you come up to like one of those battle sequences, and you're like running through the world, whatever, and it's like, ooh, battle, and it doesn't matter where you are in the scene, doesn't matter what's going on, it's just like it does this crazy sort of like swooshy effect, and then you're suddenly in the battle. So, I don't know if they use render textures, they probably did something along those lines, but render textures can definitely do.
Directly to the frame buffer. They didn't have render texture.
Right, but you know what I mean, along the same lines. Basically a snapshot of your scene. You can take that image, you can do whatever you want with it. Could be something handy for going to a game menu. Maybe you want to take a quick snapshot of whatever's going on and you want to fade everything to black and white and pull your UI up over top of it. Anything along those lines. So, just show you kind of what I put together. It is anywhere in here. Basically a crazy swirl effect using some of the, ooh, what's going on here? Oh, that's just Unity crying. It's fine. Not actually an error. But yeah, anywhere we catch this as it's rotating around, we can just get it to do some crazy swirl. And that could be really any effect at all that you want. Actually, again, pretty simple to get something like this running. I've got actually a number of scripts here. I'll go ahead and open some of these up and show you sort of what I've put together. If MonoDevelop cooperates with me. And we got screenplay, this one, and this one. All right. So this is my main script, kind of controlling it. And when I was setting this up, this is kind of I always like to do a bit of pseudocode whenever I have a main idea or like an overarching idea of how I want it to work. So I've just kind of left the comments in from what I did. So all it's really doing is I've got a class here called Camera Snapshot that grabs that snapshot texture of the scene. It sets the, I've got it right here, sets the texture onto a plane that is already sitting in the scene, turning off basically all of our scene objects so that we have nothing but our render texture displayed, and then of course disabling a couple cameras, and then turning on the transition effect that I built. So if we actually look into these a little bit further, I'll start off with the screen plane. So what I put together here is a class that originally we were using for, it was in another project where we needed to do full screen videos, but I thought this was a great opportunity to use it again here. All it does is draw out a mesh plane, the exact viewport size. So it'll always be, screen.width, screen.height, whatever you're looking at, which is perfect for taking a screenshot of exactly what you're looking at. You've got already a plane ready to go, slap your texture on it, turn off the rest of your cameras, and there you are left with a still frame of your game, which you can do anything that you want with. So that's basically all this is doing. I won't go into a lot of the details here. Just some general mesh creation, a little bit of screen to world point, but that's all this class is basically doing. Now, camera snapshot, this is where we're actually dealing with the render texture itself. And you see here, I'm creating a render texture script, just pretty basic settings. And got my little update loop, just the one key. You can have it to fire off with anything, maybe make it a public method, call it from another script, or have it fire off on some other event that's happening. And then basically I'm just using on-post render and enabling the camera for a split second and disabling it, so I only get a single frame of our scene. And then I just fire off an event, pass the texture back to our main script, and we can do whatever we want with it. So the reason that I'm using on-post render for this is at that point in our script, in the whole process of it rendering its frame, we know that it has all the data for what's in your scene. So it's a great time, or a great example of one of those methods that I'd mentioned previously. These can come in handy for a lot of the different effects that you want to do. Post-render, pre-render, anytime that you want to do a little bit of finagling, you can just drop it in there and have nice fine-grained control over what it is that you're doing. So that's pretty much all this is doing. Grabbing a quick frame and passing it back. So you can see here this on-camera snapshot. It's getting picked up by our main logic, and then once it's done, I know that I've got my render texture, and I can go through and do all the rest of the effects. So we turn off a couple cameras, set a couple things active or inactive, and then the swirl transition is one of Unity's built-in, where is it? There we go. It is, yes, it's one of its built-in vortex effect things, whatever, image effects. And I believe those are pro only as well. I'm not sure. But you could make that anything you wanted. You can always make your own, it's basically just a shader with a script. Again, for ease of use and speed, I just picked one that I thought was kind of cool looking. Basically, all the script does is sort of increment these values of x and y, swirl it around, and I kind of have it set to a speed that's just wired up to time.delta time. And that's really it as far as it works. So we go in, we've got our main camera viewing the scene. As soon as I hit the button, main camera turns off. Sorry, render texture is grabbed, main camera turns off while the other one's enabled, and it starts the swirl. So those are very handy and pretty direct to set up and use. Yes?
How much different would it look? I remember earlier you had it so it showed a transparency, but it kept it you could see all of his movement in the background. And then before that you had it so you could see the whole thing, I guess all physically there. I'm wondering if you just rotated the camera fast, how would that look?
that could be pretty interesting. I don't know. I mean, that's something you could try out and see exactly how it would work. That could be kind of cool looking if maybe you tossed a blur on it or something. The only bad part about doing that with 3D models is, you know, you have all the lighting and shading around on it, so as it's overlapping, you can really clearly see it. So maybe that's the effect that you're looking for, then that would work perfectly. But yeah, pretty much you can do any kind of effect once you've grabbed that render texture, or even beforehand. You could just set it to twirl or do whatever it's going to do, stop your camera, and you know, have it right to the texture that whole time. That is definitely a viable approach.
You could also do that with a regular camera and you can just turn it on clearing.
Yeah.
To see what that looks like, what
Yeah.
that effect looks like.
Why aren't you using camera.render instead of, like, you've got this kind of update loop, and then you're tricking it to get just a split second of the camera turning on and off,
Right.
so you can get your render texture? Why not just use camera.render to do it?
So camera.render, in the past, I've tried, like, I have used camera.render in the past, and camera.render can be kind of tricky because you can forcibly, like, basically it forces the camera to render whatever it sees. Now, in my experience though, if you call that at the wrong time, for instance, you're not necessarily going to get everything that's in the scene. Like, if you call camera.render before everything is done, it's not really, I don't know, I feel like that can be out of order of the, like, natural sequence of Unity's events. If you let it just handle all of your code gracefully in on-post render, you know for a fact that you've got every single bit of your scene there and ready to go, everything's rendered, and that's essentially why I always use on-post render.
A lot of the Unity full screen effects are doing exactly this. They're taking, you know, whatever's in the frame buffer and doing
Mhm.
something to it before presenting it to the user.
Mhm.
And they all use camera.render. I don't know what the order is, though. There could be some trickery they're doing there, but just...
Well, the other thing about camera.render, I believe you can have a camera disabled and call camera.render. You could potentially toss that into an on-post render, and you have your split-second frame that you could grab as well.
How does, well, along those lines, like camera.render, does that also count for other post-processor effects that, like, multiple post-processor effects on something? How would that handle? You know, so you have that whole, like, some other script could be editing the buffer at the same time, but
Right.
there's two scripts that are trying to, like,
So
for that.
something that's really weird about Unity's post-processing effects, or I'm not 100% sure on how the process for this works, but I do know, for instance, this vortex effect script, if I had another post-process script on here, and another one, the order of those matter actually in the inspector. So I've had times before where, actually just recently on a project, I had like a blur and like a depth of field. There was a couple things that I was using on a camera, and for some reason or other, I changed a few things around, and I went to try it out, and the way that the scene was set up, you couldn't really tell whether the up was up or the down was down. Everything was sort of symmetrical. And I started checking my motion, and everything was reversed. And I was like, what is going on? Like, I thought my control script had gone wrong, or, you know, something else had been modified. And it ended up being just the order of operations on these image effects over here. There was one of them that I just shifted upwards, and the screen was actually being rendered upside down just based on the effect of these things. So how those play into your own script, I would say follow the same suit of, if you want it to happen before, like, all these effects happen, then toss it before on the stack. If you want it to happen after, then, you know, just put it in there where it needs to go. Go ahead.
If you just started the coroutine and just the yields away from end of frame, would that be the same as post-render? On post-render, when you do a yield away for end of frame, is it the same setup?
Yeah, it pretty much is.
Also.
It pretty much is.
So you
All
do
right.
that texture on like a wall or a 3D model of the TV.
Yeah, absolutely.
When you cast a shadow on it, does it cover the texture or?
Well, So are you talking about the, like, specifically the shadow example I just gave earlier?
No, like projector playing the video.
Uh-huh.
And so we slip between it, you see a shadow on video.
Yes, if it's using a projector, then yeah, it'll cast onto anything that's around in the scene. So it's nicer than what I've got in the presentation here currently. If you're just using a single plane, then it's pretty much bound to your ground plane or however you may move it manually. But if you're using a projector will project onto pretty much anything that you have in your scene. So, like, you know, here I've got a shadow that's going down onto the floor, up onto the wall behind me. Anything like that, it'll cast across all of your objects. Cool. All right. Any other questions? Good. Okay. I just like checking. Okay. So, another popular use, security cameras. So standard. Most popular use, security cameras. I couldn't pass up a chance to do some security cameras because we don't have any reason to do security cameras in a lot of our projects. So, I got a bunch of security cameras in here. One thing that I wanted to show that can be kind of cool for render textures and security cameras, though, is, and you'll notice here I'm using InGUI in this, pretty much just so that to save my own sanity. I hate the current UI system in Unity. It's so painful to do a lot of things with. Not completely unworkable, but for the time frame that I had to put this together, InGUI just makes things a lot simpler. So basically, what this is doing is all of these cameras have, of course, a render texture and a simple label attached to each one of them. So each one will be labeled Cam 1. We got a little like time frame thing hanging out here. And of course, you wouldn't see that in the actual game, right? Like it's not visible in the scene, but well, they could be. That might be kind of cool. But you can see that gets rendered out to all of your render textures. You can see them updating. So yet again, just another use for render textures. Very handy for anything. Trying to think of anything else I wanted to cover on this topic and everything else. This was all. Sorry?
Are they like following the labels? Because I saw one label went through the wall and I'm wondering what if you put the labels on the TV itself?
So the label is actually floating in 3D space, and yeah, you can see it here. I think, which one was it? I thought I noticed that before, but I thought maybe I was imagining. Yep, there it is. There it is. Awesome. So, totally my fault. But you'll notice on, let's see, where are we? Camera 4, where are you? I'm gonna go right over to camera 4. There he is. Yeah, they're just objects floating in 3D space. So you can see right there, it's just totally clipping right through the wall. So you get around that by, yeah, maybe setting a different, like a render queue on it, different shaders, something like that. Or just make sure that your camera doesn't rotate that far. That could work too. But yeah, you can jam any number of UI things in here, a lot of stuff that you can just update on the fly, and it just adds a little bit of an extra, just some extra niceness, I think, to your security camera feed or whatever you may use it for. Have some dynamic content running on the fly. It's much better than having a texture, like an image sequence of just pre-baked numbers or something along those lines. So, there's our awesome security camera setup. There's my little guy chilling out over here.
You also put some
There we go.
post-processor effects on those, like if it was a heat vision one, to highlight heat.
Absolutely. You could have whatever kind of yeah, post-process effect, maybe even like a nice static sort of line going across it. Same thing even if you wanted to do some UI effects built into that too. You could have some other animations happening on there. Very convenient. So, all right. Moving right along. Last and not least, interactive menu using render textures. All right. I know this looks super fancy. So, we had a project not too long ago where we needed to have basically a menu, but it needed to be displayed on a three-dimensional object that would animate, but we could still interact with it, click buttons, do whatever. So you can definitely achieve that with render textures. So if we hit play here, you can see we've got this nice little 3D book and basically just some texture maps applied to it, but they're all clickable buttons. So the way that this is working is using some ray casting, and we've got our UI set up here, which is generating our render texture. Our render texture is then applied to the model, just as you would normally apply a material or anything like that. And then from the camera that's actually viewing this, we're just casting a ray. So let me just put this over here, see if we can see it all at once. I'll put it down here. There we go. And there. So you can see we've got a ray being cast here, which detects that it's hit the page object, the book object, whatever it may be, and I'm running a method that grabs the UV texture coordinate. I'm then taking that texture coordinate, which is basically just a percentage, it's 0 to 1, converting that to screen space and reprojecting the ray from our UI camera. Once that happens, then that ray, if it collides with a button element or whatever it may be, that fires off a new event like a press or an animation or whatever you would want it to do. But we can click like mad here, and you can see all these rays just shooting out all over the place. But they pretty much line up 1 to 1.
How are you getting the UV coordinate? How are you getting the UV coordinate?
It is, I don't remember the method name. Let me bring it up real quick. It's actually this fancy named UI 3D clicker.
I wonder what that is.
Here we go. That's right. Basically just grabbing the texture coordinate of the hit point. Once that happens, we've got, viewport point to ray, which converts it out to... Did you just raise your hand, Jason?
No.
Okay. I thought you raised your hand. Sorry. Right. Texture capture, 4-point array. So that does the conversion to cast it out as another ray. And it checks the next hit that it gets, and then basically just checks to see if it has a button. There's probably, more optimal ways to do this, but for the moment, this gets the job done. And if it does find that it's hit a button object, it just calls the onPress method of that button. In turn, the onPress method is being listened to by, where is it? Is it my Trogdor logic? It is. And so once it gets its onPress, it just does whatever methods are there. Oh, it's coming up. It's coming up. Last but not least, you can also do movie textures on render textures. So you can have a video play as well.
Every week I hope that it's from a theme.
Sorry, we just turned it down a little bit, kind of loud. There we go.
Man, not from a female. Hey, strong man, can you draw
So
a dragon?
plenty of things that you can do with render textures. I think they're pretty versatile. It's just sort of like one of those things where you're just kind of limited by your imagination, or it might even come out as, just a matter of necessity. I gotta turn this down a little bit more. My God. There we go. Turn it back up again. Or if you guys want to watch it, we'll just let it go for a minute. For those of you who are not familiar with Homestar Runner or Strong Bed, you're in for a treat.
Then you add some legs, throw on a couple of arms, and whoa. Wait a minute. I think I need to start over. This thing doesn't look natural. Okay, starting again, the same way. S, more different S. Close it up real good at the top for his head, and then, using consummate V's, give him teeth, spinities, and angry eyebrows. Now you can add smoke or fire, or maybe some wings. You know, if he's a wing-a-ling dragon. Let's put one of those beefy arms back on him for good measure. It looks really good. Coming out of the back of his neck there. Now he needs a name. How about Trogdor the Burninator? Oh yeah. Check out all his majesty. There's my dragon, Kaiser. Let's see how the other students are doing. All right. What do you got for me, Coach Z?
Take a look there. I think she's
So
looking
before the
pretty good.
song starts, there's a
I said
song.
consummate bees. Consummate.
Are there any questions along with this? Yes.
Strong man. You just keep doing your thing, man. Get out of my house. Oh crap! I didn't know you were doing one.
Oh, sure.
No, just wait. Describe it again.
You're a squirrel, Shady.
Prove on your methods.
That's not an improvement.
Oh, well, your render texture is basically being applied to any object. Being applied to any object through a material. So you can do offsets through that. You can do tiling, basic material sort of things. It also makes a difference in where your camera's looking too. So if you wanted to scale something down or move your camera back, you can also control placement or sizing simply by moving your camera. I think they actually made a game of this already, by the way, like from forever ago. Did they make a Flash game? It's ridiculous. Completely ridiculous. So, I'm sorry, does that answer your question? Okay. And I'll turn that down. Yeah, you can map it to anything that you can put a texture on, basically. Consummate Bees. Alright. Cool. So I think I've kind of covered it. I know I went through them kind of fast. There's a lot of other pieces of this kind of like underlying, but I think that's kind of a good overview of render textures and, you know, the usage across the board. So if there are no further questions, then I'll pass on to Chris.